For the last half-century, humanity believed it had finally mapped the fundamental architecture of reality. We constructed a magnificent mathematical framework known as the Standard Model of Cosmology, the Lambda-CDM model. It was our ultimate cosmic ledger, an elegant equation that accounted for the expansion of space, the invisible scaffolding of dark matter, and the repulsive stretch of dark energy. According to this blueprint, the universe began in a singularity 13.8 billion years ago, underwent a brief period of hyperinflation, and then slowly, meticulously cooked matter into stars, galaxies, and clusters over billions of years. It was a comfortable story. It suggested that our laws of physics were absolute, our instruments were flawless, and our understanding of time was secure. But science is not a monument to permanent truth. It is a history of constructive collapse. Today, that comfortable story is unraveling at the seams. Across the globe, astrophysicists and cosmologists are quietly admitting to a profound and exhilarating panic. The data flowing back from our most advanced spaceborne observatories is no longer matching the equations on the blackboard. We are not just missing a few minor variables or miscalculating the dust lanes of distant nebulae. Instead, our most foundational assumptions about the birth of the cosmos and the behavior of spacetime are colliding head-on with an undeniable wall of empirical evidence. The cosmic ledger does not balance. We have arrived at what is now officially recognized as the crisis in cosmology, a historical turning point where the universe is refusing to comply with our textbooks, forcing us to confront the terrifying and thrilling possibility that our operating system for reality is fundamentally incomplete. The catalyst for this modern intellectual revolution sits 1 million miles from Earth at the second Lagrange point. When the James Webb Space Telescope deployed its golden hexagonal mirrors, its primary mission was to act as a cosmic time machine, peering into the deep infrared past to witness the very first generation of stars turning on in a cold, dark universe. Cosmologists expected to find small, chaotic, disorganized clumps of primordial gas, proto-galaxies that were just beginning to coalesce under the weak gravitational pull of early dark matter. According to the standard timeline, it should have taken at least 1 billion years for matter to organize into highly structured, massive stellar systems. Instead, Webb looked back to a mere 300 million years after the Big Bang, and found something impossible. Scattered across the primordial dark were fully formed, highly evolved, and monstrously massive galaxies. These systems, colloquially dubbed universe breakers by stunned researchers, contained as many stars as our modern Milky Way, packed into incredibly compact regions of space. They were mature, structurally organized, and radiating with a fierce intensity that defied every supercomputer simulation in existence. To put this into perspective, finding these galaxies in the infant universe is the evolutionary equivalent of opening a prehistoric fossil layer from the dawn of life and finding the skeletal remains of a fully grown, anatomically modern human. They simply should not have had enough time to grow. There are only two logical conclusions to draw from this data, and both require us to rewrite history. Either the rate at which gravity pulls matter together in the early universe was vastly underestimated, meaning our understanding of gas dynamics and dark matter clustering is flawed, or the universe itself is significantly older than 13.8 billion years. If these impossible galaxies required billions of years of steady star formation to reach their observed maturity, then the chronological clock of the cosmos must be reset. The pristine infrared data from JWST has effectively shattered our neat cosmic calendar, proving that the dawn of time was not a slow, dim awakening, but a brilliant, rapid explosion of complexity that our current laws of physics cannot explain. While the early galaxies break our timeline, a second, equally devastating fracture has appeared in our measurements of the modern universe. It is a mathematical civil war known as the Hubble tension. At its core, the problem is simple yet catastrophic. We have two flawless methods for measuring how fast the universe is expanding, and they fundamentally disagree. The first method looks at the ancient universe. By utilizing satellites like ESA's Planck Observatory, scientists mapped the cosmic microwave background, the faded afterglow of the Big Bang. By measuring the tiny temperature fluctuations in this primordial light, cosmologists can feed the data into our standard model and predict exactly how fast the universe should be expanding today. That calculation yields a precise speed, roughly 67.4 kilometers per second per megaparsec. The second method ignores predictions and looks directly at the modern universe. Astronomers use what they call the cosmic distance ladder. By measuring the precise brightness of specific pulsing stars called Cepheid variables and matching them with the explosions of Type 1a supernovae, telescopes can physically measure how fast local galaxies are rushing away from us. This direct observation yields a drastically different number, approximately 73 kilometers per second per megaparsec. For a long time, scientists hoped this discrepancy was merely human error, a calibration glitch in our instruments, or a misunderstanding of cosmic dust. But the James Webb Space Telescope was recently turned toward these exact same stars to settle the debate. The result was definitive. The measurements are correct. There is no error. The universe is physically expanding faster in our local neighborhood than our equations for the early universe say it should. This is not a trivial debate over decimals. It means something fundamental is missing from our understanding of space-time. It is as if we measured a child's growth pattern, infancy, built a perfect mathematical model of their adult height, and suddenly discovered they grew up to be twice as tall as physically possible. The two eras of the universe refuse to speak the same mathematical language. To resolve a crisis of this magnitude, we must look into the dark. The Standard Model of Cosmology relies heavily on two invisible placeholders: dark matter, which acts as an invisible gravitational glue, and dark energy, which acts as a cosmic accelerator. Together, they make up 95% of everything that exists, leaving regular atoms, the stuff that makes up stars, planets, and human beings, at a mere 5%. For decades, we treated these placeholders as solved constants. We assumed dark matter was a cold, collisionless particle that simply sat there, generating gravity, and dark energy was a smooth, unchanging cosmological constant operating uniformly across time. The current crisis suggests that our placeholders are breaking down. If the universe is expanding faster than anticipated, dark energy might not be a constant value at all. It may be dynamic, a shifting force that grows stronger over cosmic time, actively tearing space apart at an accelerating velocity that our older models could not predict. Alternatively, our understanding of dark matter might be fundamentally flawed. If dark matter particles interact with each other or possess a subtle, non-gravitational pressure, it would completely alter how early galaxies formed, explaining the massive structures JWST discovered shortly after the Big Bang. We are realizing that the invisible foundation upon which we built our entire cosmic narrative is far more complex, fluid, and mysterious than we ever dared to imagine. Throughout history, humanity has panicked whenever our models of the sky have shattered. When Ptolemy's geocentric circles could no longer predict the paths of the planets, we were forced to accept that the Earth was not the center of creation. When Newton's absolute laws of motion failed at the speed of light, Einstein forced us to accept that time and space are malleable fabrics. Every great crisis in cosmology is disguised as a failure, but in reality, it is a triumph of human curiosity. The anomalies we are witnessing through the lens of the James Webb Space Telescope are not signs that the cosmos is broken. They are signs that we are on the precipice of a grand intellectual awakening. The universe is proving to be vastly more intricate, adaptive, and profound than the rigid boxes we attempted to fit it into. We are standing in the dark, watching our old textbooks burn in the light of new data, and preparing to write a new chapter in the human Odyssey. We do not look into the void with fear, but with an insatiable hunger to understand. For it is in the moments where our equations fail that the universe truly begins to speak to us. Thank you for exploring the Odyssey of science with us. Thanks for watching.